Welcome to our YouTube channel. This is Ernest coming to you from Math Lab Tutorials in Toronto, Canada. Our mission impossible is simply to convert some of that math hate to math love. As your screen says, like it or not, math really did take us from the Flintstones era to the Jetsons era. Now let's get down to some serious math. Hello there. This is a continuing series on BEDMAS. This will be video 3. And we're going to be dealing with order of operations again. But we're going to be dealing with expressions that contain exponents or expressions with exponents. Some preliminary notes first. When you see a to the power b, an expression like a to the power b, a is called the base and b is called the exponent. The base should be strictly greater than or equal to 0 for the time being, and the exponent for the time being will be the set of positive integers or positive integers or the set of whole numbers. Okay, so the exponents we'll be dealing with will be exponents from the whole number system, but the base will be any number greater than or equal to 0. So a to the power b over here, this is really a short form. It really means a times a times a times a, etc. times a. And there are BAs. So it would be a dot a dot a dot a, b times. So there are BAs in this product string. How many A's are there? Of course, the answer is B. So B is really a frequency count for the number of A's that are being multiplied. Again, B, the exponent, is a frequency count for the number of A's that are being multiplied in the product string. Some examples. 2 to the power 4 is short form for 2.2.2.2. What's the frequency of 2's? It's 4, the same as the exponent. And of course, 2.2.2.2 is just 16. 3 to the power 5 really means 3.3.3.3.3. How many 3's are there? There are 5 3's. So 5 is the frequency count for 3. So the exponent is just the frequency for the base, which is 3. And of course, the result is 243. Over here, the base is -2 this time. I had said previously that the base should be greater than or equal to 0. But when we're dealing with integer exponents or whole number exponents, I don't want to deal with negative exponents right now, but when you're dealing with whole number exponents, you're allowed to have a negative base. That's really not a problem. Problems occur later on when the situation gets a little bit more complicated, but we won't delve with that case right now. So -2 to the power 3 really means -2 dot -2 dot -2. When we count how many -2's we have 3. And when we do a neg count, how many negatives do we have? We have 3. So when we look at -2 to the power 3, we really have a neg count of 3. Because in expanded form over here, you can clearly see the 3 negatives. In compressed form or short form, that negative really means 3 times. There are 3 negatives involved. So the neg count is 3, and of course 3 is odd, so the result is negative. And then you do 2 to the power 3. You disregard the negative signs like we did before. Just disregard all the negative signs. You do a neg count. The neg count is 3. You put a minus sign out front. and the resulting base is just 2, and you do 2 to the power 3. Of course, the answer is minus, and then 2 to the power 3 is 8. Okay, so let's look at this rule down here. If you ever see bracket negative a to the power b, the negative occurs b times. Of course, the a occurs b times as well. If the negative occurs b times, that means that we have two cases. Either the count is 0, 2, 4, etc. In other words, we get an even count. If we get an even count, where the neg count is really even, so the final result is negative. Actually, the final result is positive, sorry. If the neg count, again, which is b is really counting the number of negatives. If the neg count is 1, 3, 5, etc., in other words, an odd negative count, then the result is negative, and we'll write down minus a to the power b. So again, if b is even, the resulting expression becomes plus a to the power b. If b is odd, the resulting expression becomes minus a to the power b. Okay, so I call that the even-odd rule for exponents. So let's go on and do some questions to get some practice. Let's look at Q1. It says use order of operations to simplify the following expression. And we have minus 2 to the power 3 dot 3 to the power 2. We identify one cluster. Why? Because of the dot in between. And we identify a neg count of 3. Why? Because that negative sign is right there and the count is 3. There are no negatives over here. So the neg count is 3. And of course 3 is odd, so the result is negative. Then disregard all the negatives and write 2 to the power 3 dot 3 to the power 2. Of course 2 to the power 3 is 8, 3 to the power 2 is 9. At the end 8 dot 9 is 72. And you drop the minus sign down. So the result is negative 72. Let's look at question number 2. We have negative 2 to the power 4 dot negative 3. Then a plus sign indicates we have another cluster, 2 to the power 3 dot 5. So when we look at this expression carefully, because there's a dot between the brackets, we identify a cluster. The plus sign is a separator between the clusters. And because there's a dot over here, we identify this as a second cluster. So we have cluster 1, cluster 2. If we do a negative count for each cluster, we get a negative count of 4 here and 1 there, so a total would be a negative count of 5. So we get 4 negatives here, 1 negative there. The neg count would be 5 for the first cluster. Write down a 5 for the neg count. Over here, when you count the number of negatives, you get none, so you put down 0. Of course, 5 is odd, and 0 is even. So the first cluster is negative, the second cluster is positive. So we put a negative sign over here, drop all the negatives, and you write 2 to the power 4 dot 3. Over here, it's positive. That's what we set up here. It would be positive for the second cluster. And we have 2 to the power 3 dot 5. And then we simplify each cluster in turn. 2 to the power, we drop the minus sign down because we're done with the minus sign. 2 to the power 4 is 16. Of course, 3 is just a drop down. Drop the plus sign down. 2 to the power 3 is 8. And 5 is just a drop down. So then you drop down the negative, and 16.3 is 48. Drop the plus sign down, 8.5 is 40. At the end, you have 48 bad guys fighting with 40 good guys. The bad guys win by 8. And the final result is negative 8. Okay, so you can go over that carefully. Let's go on to the next slide. Let's look at Q4. It says use order of operations to simplify the following expression. Again, we're going to be looking at this carefully. We have minus 1 to the power 3, dot negative 2 to the power 2, 3 to the power 2. Then there's a separator over here. The minus sign is a separator. So we identify this as one cluster because there are dots in between. There's the separator, so it's the beginning of the second cluster. So then we have negative 2 to the power 3 dot 3 squared. That will be the second cluster, C2. And then we have a minus sign, which is a separator. So that means we have another cluster coming up. And the other cluster is negative 1 squared dot negative 3 cubed. So again, we have three clusters, C1, C2, C3. And we're going to do a neg count for each cluster. Be very, very careful when you do the neg counts. Let's look at C1 and only C1. We get a neg count of 3 here, neg count of 2 here. Altogether, we get 3 plus 2 is 5. So we get a neg count of 5. Over here, we have 1 negative and then 3 negatives. We'll give you 4 negatives, so the neg count is 4. Over here, we have 1 negative, 2 negatives, and 3 negatives. So the neg count is 6 altogether. Now, 5 is odd, so the result of the first cluster is negative, and 4 and 6 are both even, so the second and third clusters are both positive. So we drop down a minus sign for the first cluster, and then we write 1 to the power 3. We write down 2 to the power 3, and 3 to the power 2. Notice we disregard all the negatives after we do the neg count. Let's look at the second cluster. We know it's positive right there. Second cluster is positive. And then we disregard all the negatives, henceforth. Write down 2 to the power 3, drop it down. 3 to the power 2, drop it down. The third cluster is positive, so we put a plus sign down. And then we drop all the negatives. We have 1 to the power 2. And then 3 to the power 3. Okay? So, again, we have the three clusters. Cluster 1, Cluster 2, Cluster 3. We've already done our neg counts for each cluster. So now it comes down to evaluating some products. 1 to the power 3 is just 1. 2 to the power 2 is 4. 3 to the power 2 is 9. 2 to the power 3 is 8. 3 to the power 2 is 9. 1 squared is 1, and 3 to the power 3 is 27. So now we continue to simplify each product. Drop the minus sign down. 1.4.9 is 36. Drop the plus sign down. 8.9 is 72. Drop the plus sign down. 1.27 is 27. Now we have a simple integer string at the end. We have some good guys and we have some bad guys. Okay, so we open up a plus bin, drop in a 72 and a 27. Then open up a minus bin, drop in a 36. Then we simplify inside each bin. 72 plus 27 is 99, and 36 is just a drop down. Now we got 99 good guys, 36 bad guys. The good guys obviously win, so you put a plus sign and then do large minus small. 99 minus 36. So that'll give you plus 63. At the end, you can drop the plus sign, and the result is 63. Okay, let's go on to the next problem. Question 7. Again, we're going to be using order of operations to simplify the following expression. We have bracket negative 3 plus 4 minus 5 dot bracket negative 4 plus 2 to the power 3 dot negative 1. Then we hit a separator. That means that this is all one cluster. There's a dot there between the brackets. So we identify a single cluster right there. There's the separator right there. Then we have bracket negative 7 plus 5 to the power 2 dot bracket negative 4 plus 3. Again, because of the dot, we identify this as a cluster. So altogether we have two clusters. The next operation is to do the DMFs inside the brackets. Recall the DMF means do me first. So BEDMAS says do the operation inside the brackets first. And that's what we're going to do. So that's a DMF, that's a DMF, that's a DMF, and that's a DMF. That's what we're going to do next. Okay, so if we look inside this set of brackets, we get 4 good guys, 8 bad guys. This set of brackets, this over here, 4 bad guys, 2 good guys, and 4 bad guys will give you -2. And the -1 is just a drop down because there's nothing to do. And then we have 5 good guys, 7 bad guys will give you -2. Of course, you have to drop down the squared. And then 3 good guys, 4 bad guys will give you -1, and just drop down the -1. Okay, and then we have to continue to simplify the DMFs. Over here, we only have one DMF. It's the 4 minus 8. So 4 minus 8, you have 4 good guys, 8 bad guys. The result is -4. -2 to the power 3 is just a drop down. -1 drop down. Negative is just a drop down. -2 squared is a drop down. -1 is a drop down. There's nothing to do. Now that we've got all dots over here, we have simple terms. Within each cluster, we're in a position to do a neg count. Okay, let's do a neg count for the first cluster. We get 1 negative here, 3 negatives there, and 1 negative there. Total neg count is 5. We'll do a neg count for the second cluster. We get 1 here, we get 2 there, and we get another 1 here. So we get a neg count of 4 for the second cluster. Of course, 5 is odd, so the result of the first cluster is negative. And 4 is even, so the result of the second cluster is positive. So we put a negative sign out front in front of the first cluster, disregard all the negatives, and 4 is a drop down, 2 to the power 3 is a drop down, and 1 is a drop down. The second cluster is positive, so you put a plus sign. Disregard all the negatives again, and you get 2 to the power 2 drop down, and then a 1 is a drop down. Then at the end you simplify each product for each cluster, drop down the minus sign, and we get 4.2 to the power 3, which is 8, and then .1. And then drop the plus sign, 2 to the power 2 is 4, and the 1 is just a drop down. Again, you continue to simplify each product. Bring the minus sign down, 4.8.1 is 32. Bring the plus sign down, 4.1 is 4. At the end, you have a simple integer string. You have 32 bad guys, you have 4 good guys. The bad guys obviously win, and then when you do large minus small, you get 28. So the result is -28, or we say that the bad guys win by 28. Okay, let's have a look at the next problem. I think we'll do an over and out for now, okay? And again, thanks to all for viewing this video. Stay tuned for many more videos to come. If you liked the video, please give us a like and subscribe to our channel. If not, tell us how to improve it. Over and out for MathLab Tutorials in Toronto.